morning everyone. Today I am going to take a lecture on first chapter of electronics engineering materials, that is conductivity of materials. So here in this lecture I am going to discuss about the points which I am going to cover here. Here are the conductivity of materials, then the terms which are related to the electrical materials, and the factors affecting the resistivity of electrical materials we are going to discuss in this lecture. So let's get started. So first we'll discuss about the conductivity of materials. So electrical conductivity in metals is a result of the movement of electrically charged particles. The atoms of metal elements are characterized by the presence of valence electrons, which are electrons in the outer shell of an atom that are free to move about. These are free electrons that allow metals to conduct an electric current. Because valence electrons are free to move, they can travel through the lattice that forms the physical structure of a metal. Under an electric field, free electrons move through the metal much like billiard balls knocking against each other, passing an electric charge as they move. The most important properties of metals are their high temperature and electrical conductivities. Silver has the highest electrical conductivity. Copper comes next and is similar to silver from the point of view of atomic structure. Both belongs to the same group of periodic table. The conductivity of copper is less than that of the silver, whereas gold, which has a conductivity higher than that of the aluminium but lower than that of the silver or copper, and it does not find use in electrical industry because it is expensive. Now we'll talk about the terms which are related to the electrical materials. The first one is the resistivity, which is denoted by rho. So the electrical resistivity represented by the Greek letter rho, this symbol is called rho. It is a measure of the resistance of a specific material of a given size to the electrical current conduction that flows through it. It is also referred to as the specific electrical resistance or volume resistivity. The SI unit of electrical resistivity is expressed in ohm meter. The insulators have high values of electrical resistivities in the range of 10 raised to 10 ohm meter, whereas metal conductors have very small resistivity values in the range of 10 raised to minus 8 ohm meter. Resistivity depends on the resistance R, cross-sectional area A and length L. So resistivity rho is given as A into R by L. So this equation can also be written as R equal to rho L by A. So if I substitute the units of the various quantities, then we will get rho equal to here the area of the cross-sectional area unit is meter square, resistance unit is ohm and length unit is L. Then if I substitute this units, then we will get the value ohm meter. Next term is conductance. So conductance, which is also known as electrical conductance, it is defined as the potential for a substance to conduct electricity. Conductance is the measure of how easily electrical current, that is flow of charge, can pass through a material. Conductance is the inverse or reciprocal of electrical resistance, which is represented as 1 by R. Conductance is denoted as G, which is a reciprocal of resistance, so it is denoted as G equal to 1 by R. Now last one is the conductivity. So electrical conductivity is the measure of the amount of electrical current a material can carry or its ability to carry a current. Electrical conductivity is also known as specific conductance. It is denoted by the symbol sigma and has SI unit of Siemens per meter. Now let us take a minute and try to answer these questions. On which of the following factors does the resistivity of a material depend? Commonly used conducting materials are what, and what is the basic property of electrical conducting materials? As already answers are given, so your resistivity of a material depends on resistance of the conductor, area of the conductor section and length of the conductor. So answers all of these are correct. And commonly used conducting materials are both copper and aluminium. And the basic property of electrical conducting materials is to allow the passage of current through the materials. So these are the answers. Now let's just move forward and see some of the problems related to these formulas. Now the first question is the resistance of a wire of length 10 meter is 2 ohm. If the area of cross section of the wire is 2 into 10 raised to minus 7 meter square, now we have to find it out, the resistivity, conductance and conductivity. So here given values here, what are the values which here given in the problem? So here length is given, that is L is equal to 10 meter, resistance is given as 2 ohm, and the area of cross section of the wire is given as 2 into 10 raised to minus 7 meter square. Now put the value in the formula of resistivity. That is resistivity is equal to rho equal to R into A upon L. So value of R is 2, area of cross section is 2 into 10 raised to minus 7 meter square, and the length is 10. So if I calculate this value, we will get the answer 4 into 10 raised to minus 8 ohm meter. We will take the value, the denominator 10 to the upper side, then it will become 10 raised to minus 8, and the answer will become 4 into 10 raised to minus 8 ohm meter. Now we have to find out the value of conductance. We know the value of R. So 1 by R equal to 1 by 2, that is 0.15 mho, and conductivity is given as 1 by rho. So that is 1 upon 4 into 10 raised to minus 8, that is 0.25 into 10 raised to minus 8 mho per meter, or Siemens per meter. Now we will take one more problem. Here the next problem is calculate the resistance of a rectangular strip of aluminium whose dimensions are as follows. Length is given as 1.5 meter, width is given as 20 mm, thickness 0.5 mm. We have to calculate here resistivity of aluminium is given as 2.65 into 10 raised to minus 7 ohm meter at 20 degrees centigrade. So given parameters which we have write, rho equal to 2.65 into 10 raised to minus 7 ohm meter, length is given as 1.5 meter. We have to calculate the area of cross section, which is given as length into breadth. So length is given as 1.5, width and thickness, that is breadth and height, and thickness is given as 0.5. We have to multiply it, then it will become 20 into 0.5, it will become 10 millimeter square. So 10 millimeter square can also be written as 10 into 10 raised to minus 3 into 10 raised to minus 3 meter square, then it will become 1 into 10 raised to minus 5 meter square. Now put the value of the resistance. So we have to calculate the resistance. So resistance equal to rho L by A. Put the values 2.65 into 10 raised to minus 7 ohm meter into 1.5 is the length, and area is given as 1 into 10 raised to minus 5 meter square. So if I calculate the value, then you will get the value as 0.03975. So in terms of meter ohm, so it will become 39.75 meter ohm. So this is the value of resistance. I hope you have understood the concept. Now we'll talk about the factors. What are the factors affecting the resistivity of electrical materials? The first one is the temperature. So the electrical resistance of most metals increases with increasing temperature, while those of semiconductors and electrolytes decreases with increase of temperature. Many metals have vanishing resistivity at absolute zero of temperature, which is known as superconductivity. Next is the alloying. A solid solution has a less regular structure than a pure metal. Consequently, the electrical conductivity of a solid solution alloy drops off, or it falls down rapidly with increased alloy content. The addition of small amount of impurities leads to considerable increase in resistivity. Next, we will talk about the cold work. The mechanical distortion of the crystal structure decreases the conductivity of a metal because the localized strains interfere with electron movement. And last one is the age hardening, which increases the resistivity of an alloy. So these are the 4 factors affecting the resistivity of electrical materials. Lastly, we will talk about the motion of an electron in an electric field. What type of motions are there in an electric field? So in a conductor, The electrons are moving about with random velocity, the magnitude of which depends upon the temperature. So there are two components of motion. First one is the random motion and second one is the directed motion. Random motion of electrons depends on the temperature and it is of the order of 10⁶ meter per second. Whereas directed motion, here as we apply an electric field to a conductor, the electrons start moving in a particular direction depending on the polarity of electric field. Now let's just take a minute and try to answer this question. Which among the following is a unit for resistivity? Which factor increases the resistivity of an alloy? And which component of motion depends on the temperature? So as already answers are given, so among the out of this, the unit for resistivity is ohm meter. Age hardening increases the resistivity of an alloy, which is the fourth factor, and random motion depends on the temperature. I hope you have understood the concept of conductivity of materials. Thank you.